In this video, I'll discuss the different model selections available in logistic regression. In logistic regression, there are basically four type of model selection available. All the four model selections can be selected and implemented using PROC Logistic in SAS. What are the selections? Forward selections, backward selection, stepwise selection, and the last one is subset selection. The term that is used is score. So score selection. Before going into the detail, let me give you a brief idea about what these selections basically are, and why do we need some sort of a selection. Because we if you have gone through my earlier videos, I haven't really used any selection method while doing PROC logistic regression. Well, it's all about selecting variables. What happens is, when we do any modeling exercises, we have so many independent variables, and it is always recommended that we need to have minimum number of independent variables. So the lesser the number of variables, the better it is for us in the model. I mean, we may be given a lot of variables to choose from, but finally we need to have a few set of variables, and we need to have the variables which are most effective or the best predictive, having best predictive power. Selection procedure or model selection option in the logistic regression gives you that flexibility, or gives you that opportunity to select the best set of variables out of so many variables. So there are four ways of doing it. Of course, there is another way of doing it where you don't mention any selection, okay, and whatever model you have specified, that is what is taken. So well, that option is known as option or selection none. Okay, let me show you the data set that I am going to use for this. Okay, so I am going to use this data set. This data set is having information about different candidates who have applied to a graduate school. Admit is the first variable, which is my dependent variable in the model. It's a binary variable. It takes 1 if a student is admitted and takes 0 if student is not admitted. There are three more variables available to us: GRE, GPA, and rank. GRE, GPA, and rank are the independent variables in my model. GRE and GPA are continuous in nature. Rank is ordinal in nature. Okay, I'll close the data, and you can see the syntax on my screen: PROC Logistic data, and then give the dataset name. Well, the name of the dataset is lib.binary. My dataset is there in the lib library in my desktop. I'm using DESC descending because I'm going to model for the event. which is denoted as 1 in the dependent variable. I'm using class is rank because rank is a class variable. My model is admit equal to GRE, GPA and rank. So admit is my dependent variable, GRE, GPA and rank are my independent variables. How do we select or how do you mention selection in the model? I put a bar and then write selection equal to and then you can put the selection you want. If you put none, selection equal to none, then it will take the model as defined by you. There won't be any change in the model. Okay. So this is like without if you run this code without having selection criteria, that is exactly same as having a selection criteria equal to none. Okay, so if you run this, you'll get the same output that you can get even without using the selection. So it's exactly the same. It's essentially the same. There is absolutely no change at all. So although this is one of the one of the way of doing it, but if you don't want to use any selection, the best thing is that don't mention selection is equal to none. It's not required at all. Okay. So by default, selection will be none if you don't use it. So let's start with what is forward selection. So for forward selection, you have to mention forward here. Let's run this. Okay, so look at the output. You can see there are different steps in which the forward selection happens. So what is this forward selection? In forward selection, variables are selected one after another. Okay, so first thing the SAS PROC does is that it computes which one is the best variable for the model in terms of its ability to predict the dependent variable. Okay, so it computes the chi-square statistics, and the one which is having highest chi-square statistic is entered first. So in the zeroth step, in the which is not even the first step, you can see step 0. The first model is formed, which is without any variable. Okay, so that is the null model, or the intercept model. Okay, so none of the variables are there in the model. Now in the step 1, okay, so this happens one step after another, as I said, right? So 0th step, then followed by the step 1. In the step 1, the variable having highest chi-square value is entered first. Okay, so in our model, the variable rank is having the highest chi-square value, hence it is entered first. Okay, now it will see once a variable is entered, okay, it's not going to leave the model ever. Okay, so whether variable enters or not, again this is decided by a criteria. It has to be significant at 95% confidence level. So that's the default criteria. Of course, you can change the criteria, and we'll see how we can change the criteria. But by default, it has to be significant at 95% confidence level to be eligible to enter. So rank is the variable which is eligible to enter. Okay, so it enters the model. Once it enters the model, it cannot leave the model ever. It will always be there in the model. In the next step, the next variable, which is the second most important variable, or the second most significant variable, is the GPA. Now GPA enters the model. It enters because it satisfies the criteria or minimum threshold value for the significance. Then it enters. Then in the third step, GRE is entered. Even GRE satisfy the criteria, the minimum significance level criteria. But if all three variables we have satisfy the criteria, but there will be instances where certain number of variables will not fulfill the criteria. They will, if they do not satisfy to the criteria, these variables will not be included, and the procedure will stop running there. Okay, and we'll have only those variable that satisfy the criteria in the model. Okay, not the ones that did not. So finally, there is a note where it says all effects have been entered into the model. That means all the variables that we have supplied to the algorithm have met the criteria, and hence they are in the model. And finally, the model statistics is given in the analysis of maximum likelihood estimates. You can see it. So that's the way the forward selection can be used for variable selection. One of the peculiarity of forward selection is that once a variable is entered into the model, it never drops. Okay, and at each step we estimate the model again and again, right? So once a variable is entered in the model, it will never leave. Okay, even if it is insignificant inside. Okay, because when you re-estimate, right, you can see, right, there are different re-estimation. First estimation, then we re-estimate again in the step 1, we re-estimate again in step 2. So many times we estimate the model, and sometimes a variable which is there in the model can be insignificant later on in the later steps, but even that time it doesn't drop. Okay, even if it is insignificant, it remains within the model. The second type of model selection is backward selection. Okay, it does exactly the reverse way of selection. In forward selection, we start with one variable after another, right? We go on including one variable, second variable, third variable. In backward selection, it's the opposite. We start with all the variables and keep on dropping one variable after another. Okay, so let's run this. We use backward in the selection, and let's run. Okay, so in the output, in the 0th step, it writes the following effects were entered: intercept, GRE, GPA, and rank. So all the variables are entered once. Okay, then what the algorithm does is it computes the wall statistic for all the variables, and the least significant variable which do not meet the significance criteria. Remember, the significance criteria by default is 95% confidence. Okay, so the p-value has to be less than 0.05. Okay, I repeat, the p-value or the default p-value has to be less than 0.05. That's the criteria for a variable to be in the model. So it starts with all the variables, computes its wall statistic, and based on whether a particular variable is significant in the model or not, it drops one variable after another. So which variable is dropped first? The least significant variable. Okay, Unfortunately, in our model, all the three variables are significant. You can see a note here. No effect met the 0.05 significance level for removal from the model. As I have already mentioned, the p-value has to be less than 0.05, and unfortunately all our variables have met this criteria. But there will be instances wherein certain number of variables will not meet this criteria, and then one after another the variables will be dropped. So in the first step, the least significant variable is dropped, then the model is re-estimated again, and the next step, the next least significant variable is dropped, and so on till the point when all the variables are or remaining variables in the model are significant enough. Okay. The third is the stepwise selection. Well, the stepwise selection is pretty much same as forward selection. It selects one variable after another. It starts with the null model, go to the first variable, the best variable, or the most significant variable having highest chi-square, and for go on to the next one. Pretty much similar to the forward selection. The only difference is that if a variable is included in the model, it doesn't guarantee that that will always be there in the model. During the re-estimation, if one of the variable become insignificant, it will drop off, which was not there in the forward selection. Okay, so in the selection method, you just have to mention stepwise, and you can run it. So stepwise is perhaps the most popular selection method, because it uses the features of both backward as well as forward selection. Okay, so it's a bit stricter, but it's very effective. The last one is the best subset selection. Best subset selection is the selection criteria in which the combinations are tried. All the combinations are tried. Okay. Say for example, we have three variables here. So we'll have a model for all the permutation. We'll take the combination of all the variables. We can have each one of one variable at one time, and two variables at one time, and then all three variables at one time. So in total there will be 6 models, right? GRE alone, then GPA alone, rank alone. 3 models: GRE GPA, GPA rank, and then GRE rank. Another 3 model, 6, and then final model will be GRE GPA and rank. So total 7 models will be there. Okay. So out of the 7 model, which model is the best performing one? So based on certain criteria, it will select the combination of variables that gives the the most efficient model, and for that we use the selection method as score. It's known as best subset selection. So out of the bunch of variable, what is the subset of variable that is able to predict my dependent variable most efficiently? Okay. One of the feature of this selection is that it doesn't work with class variables. Since rank is a class variable, we cannot use score here, or if we want to use it, we have to drop rank from the model, or we cannot use rank as a variable in our model. Okay. I talked about the selection criteria, right? For a variable to be in the model or not, both in forward, backward, and stepwise selections. In all the 3 different selections, there is a criteria which is used. So the default criteria is significant. Default significant level is 95% confidence level, but we need not have this strict criteria. We can have our own criteria. Okay, for that we use what what is known as SL entry. Then just mention, if you in place of 0.05, if you want to mention have 0.1, just put 0.1 after the equal to sign. SL entry equal to 0.1, and then what's the criteria that variable will stay. So SL entry is the criteria that a variable will enter the model. And what's the criteria that a variable will stay in the model? It's again up to us to decide. We'll also keep it 0.1. Okay, now this is a less stricter criteria. Okay, so if you don't want to go with the default selection criteria, we can always mention our own criteria by using SL entry and SL stay. So that's about the different selection criteria in logistic regression. To summarize, there are basically 4 selection methods available to us in PROC Logistic. Of course, there is another selection method, selection equal to none, but that is again same as the model that you have defined, wherein none of the independent variable is dropped. In the forward selection, one variable is selected, variables are selected one after the other, and once a variable is selected in the model, it never drops. In the backward selection, we start with the full set of variables, and based on the significance level, we keep on dropping one variable after the other till we reach a set of variables where all the variables are good enough or meet the basic significance level criteria. In the stepwise, it's same as the forward, except that a variable once included can well be dropped in the later stage while the re-estimation happens. In the best subset selection, we can use set of variables, and automatically the algorithms gives a subset of variable that gives the best predictive power, and it doesn't work with class variable.